What we're going to do today in lesson 11.5 is multiplying and dividing rational expressions. So yesterday in lesson 11.4, we simplified rational expressions. So remember we said all that meant was simplifying fractions that have variables in them. So today we're going to be multiplying and dividing fractions with variables. But if I were to give you this, let's say I were to give you 2 over 10 times 50 over 4. And I were to say multiply. Before you actually multiplied and got 100 over 40, what could you do to make it easier on yourself so you don't have such a big answer? Reduce them, exactly. I can say I can reduce it this way. I can reduce 2/10 to 1/5. And I could reduce 50 over 4 to 25 over 2. Or I could reduce diagonally. I could say, okay, what number goes into both 2 and 4? 2. So this changes to a 1. This changes to a 2. What number both goes into 10 and 50? 10. 10 goes into 10 one time. 10 goes into 50 5 times. And then I've got 5 over 2. Okay? I can simplify or change this to 2 and 1/2 if I'd like, or I could leave it just like that. That's all that we're doing today is we've got two fractions that are being multiplied, but before we actually multiply or divide them, let's simplify it so we don't get such a big answer, okay? So in example 1, they want us to multiply the fractions. Now, remember, what you've learned in the past lessons before will come into play. So before I multiply, let's look diagonally here. Is there anything I can simplify with 7 and 14? Is there a number that can go into both of them? What is it? 7. 7 goes into 7 one time. 7 goes into 14 2 times. Now, let's look at our variables. N to the 5th power and n. Okay? Here's an easy way for those of you who get confused when canceling out variables. You say, wait a second, can I take away 6? No, that's not how it works. Basically, n to the 5th power just means n times n times n times n times n. There's 5 of them there, right? And there's 1 down here. So for every pair, you can cancel 1 set out. So how many n's would I be left with up top? 4. So technically you would have, instead of writing all of those n's, you would have n to the 4th power. And this n right here would just totally cancel out. Does that make sense to everybody? Okay. So now my new numerator is 1n to the 4th, and my denominator on my second fraction is 2. Let's do the same thing here with this fraction, 5 and 10. What is a number that will go into both 5 and 10? 5. 5 goes into 5 one time. 5 goes into 10 2 times. Now I've got 2 n's here and 3 of them up top. So how many n's can I cancel out? 2. This goes away completely. And how many am I left with up top? 1. Now, once I've simplified everything I can simplify, I just multiply straight across. So my numerators will be multiplied, and my denominators will be multiplied. 1 times 2 is 2. If I have 4 n's here and 1 n here, how many n's will I have in my final answer? 5. Remember, we just add them. If they're being multiplied, we add. And then 1 times 2 is 2. Now, this is where yesterday's lesson comes into play. Look at the fraction we have now. Is that my final answer? No. What can I cancel out? The 2's. Because 2 over 2 is technically 1. So my final answer is n to the 5th power. Or you could write 1n to the 5th power. Either one, it does not matter. Okay? So we want to simplify first before we multiply. Now, This is where you actually got to put your factoring knowledge to use. Anytime you see a positive or a negative sign, remember, these are a group. They cannot be touched unless there's something identical to them. Okay? Because I see nothing identical, I can ask myself, can I factor what I have in parentheses? Or can I take out a greatest common factor so that I can simplify? You tell me, can I take out a greatest common factor of 3y squared minus 3y? Yes, what is it? 3y. So I put my 3y here on the outside, and I rewrite what I have left. 3y squared divided by 3y leaves me with y, or 1y, minus what? 1. Because anytime you take something completely out, you're always left with a 1. It's never a 0. So basically, if I want to, I can cross this out because what I have written underneath it is my new denominator. Let's do the same thing with the next denominator. Y squared minus 6y plus 5. Okay, let's factor that. Let's list the factors of 5, which are 1 times 5, and that's it. Are they going to add to give me 6? Yep. So I write y in 1, y in 5, and what are the signs going to be? Negative, negative. Remember, because they want to add to give me negative 6. So if they're opposite signs, positive 1 minus 5 is going to be negative 4. Or if it's negative 1 plus 5, that's going to be positive 4. So we can't do that. They've got to be the same signs. So now I can cross this denominator out because what I've written underneath it is my new denominator. So let's look diagonal. First of all, look right here at this set of parentheses, y minus 1. Is there another y minus 1 up here that can be canceled out? No. So it's totally off limits. I can't touch it. But I do have a 3y and a 2y squared. Do you see anything that can be canceled out here? The y's. Cancel this one out, and how many am I left with up top? 1. Okay, is there anything left for me to do diagonally on this fraction? Not on this side, okay? But let's look at this one right here. Do you see anything identical that can be canceled out? Y minus 5, so I cancel out here, cancel out here. Then I just multiply straight across. What happens when everything's totally gone on the top of a fraction? What am I left with? A 1. So I say 1 times 2y is 2y over 3 times y minus 1 times y minus 1. When you have something like that, you can leave the number that's on the outside and just write exactly what you have still in parentheses. I don't actually have to do FOIL and multiply it out. This can be my final answer here. All right, let's look at this next one. First of all, this is not a fraction at all. But because I'm multiplying with fractions or rational expressions, I want to make it a fraction. So how would I make 2x minus 3 a fraction, Zoe? Put it over 1. Exactly. That way I can just kind of see. It makes it easier for me to see, oh, okay, I would be multiplying 2x plus 1 times 2x minus 3 and 2x squared minus x minus 3 times 1. Okay? First of all, we already know this is off limits. This has already got parentheses around it. It's off limits, okay? And is there any greatest common factor I could take out of this set of parentheses besides 1? No. So I'm not going to touch it. Is there any greatest common factor I can take out of this set of parentheses besides 1? Nope. So I'm not going to touch it, okay? But what can I do to this denominator? AC factoring. So we multiply 2 times 3, which is 6. List the factors of 6, which are 1 times 6 and 2 times 3. Which ones will subtract to give me, what's this number right here? 1. So we've got 2 and 3. Now remember, My factoring is not going to be x plus 2x minus 3. That's not how AC factoring works. We go back to our original problem, 2x squared. Then we plug in our factors that we chose. So I'm going to put plus 2x minus 3x. Then finish writing the rest of the original equation, minus 3. Then I'm going to do my factor by grouping. What is the greatest common factor of 2x squared plus 2x? 2x. Write that right down here. I'm not sure if you can see it. And I'm left with x plus 1. What's the greatest common factor of negative 3x minus 3? Negative 3. And I'm left with x plus 1. Okay, now I'm going to totally rewrite this fraction so that it's nice and clear to you guys. So my numerator, I have 2x plus 1 over my new factor denominator is going to be 2x minus 3 times x plus 1. Then I'm going to be multiplying it by 2x minus 3 over 1. Okay? Now, is there anything I can cancel out diagonally here? No, there's nothing. Can I cancel out the ones? Because this right here is a pair. We cannot touch it unless there is another 2x plus 1. So those ones are off limits. It's not being multiplied, it's being added. Now look this way diagonally. Is there anything that you see that's identical? What is it, Tyreek? 2x minus 3. Because it's identical, I can cancel it out totally. So, since there's nothing left here, I put a 1 there, and I just multiply straight across. 2x plus 1 times 1 is 2x plus 1. And x plus 1 times 1 is x plus 1. Now, this is where people make a mistake. Because they get so excited, they go, oh, x plus 1, x plus 1. They're identical. So my answer is 2. No, they are not. This is a unit, 2x plus 1. Unless there is another 2x plus 1, there's absolutely nothing you can cancel it out with. This is x plus 1. It is a unit. It's a pair. There's absolutely nothing you can cancel it out with. So this is my final answer. Okay? Now in example 3, what we're going to do is we're going to divide. Okay? Now, here we go. You know that we never, ever, ever divide fractions. Remember, we flip, we do the reciprocal, and change it to multiplication. But am I going to flip, am I going to flip both fractions? No. Which fraction do I flip? The second one. So I don't touch my first one. I have n minus 2 over 2n. I change it to multiplication, and my new second fraction is going to be n plus 5 over n minus 2. Okay? Let's go ahead and put parentheses around what's off limits. Hebron, what is off limits? Perfect. Do you see any identical pairs that can be canceled out? What is it? N minus 2 and n minus 2. Then I just multiply straight across. So I've got 1 here and a 1 here. 1 times n plus 5 is n plus 5 over 2n. Is there anything I can cancel out now? No, because this n plus 5 is off limits. Remember, unless there's another n plus 5, I can't touch it. So this is my final answer. So division is the exact same thing as multiplication. We just know we've got to keep, flip, change. Remember that? So we flip the second fraction, change it to the reciprocal, and change our equation, or I'm sorry, our expression to a multiplication. So what happens if the second fraction, the second problem that you have is not a fraction? Make it 1. That way I can clearly see, okay, when I flip it, it's going to be 1 over x minus 4. So let's rewrite this problem. We have 5x minus 20x I'm sorry, 5x squared minus 20x over x plus 5 times, my new fraction is going to be 1 over x minus 4. All right, let's go through and mark off or put parentheses around what's off limits. What is off limits? 5x squared minus 20x, x plus 5, and x minus 4. Now, look at all your parentheses. You always want to do this and ask yourself, is there a greatest common factor that can be taken out, or can I factor it? Tyreek? What am I going to do? Okay, I'm going to take a greatest common factor out of here because I see, okay, I can reduce it. I can pull something out so that it can be simplified. What is my greatest common factor? 5x. Perfect. So I pull that to the outside. My new first term is going to be x. My new second term is going to be 4. So if I want to, I can just kind of cross this out because I know it's no longer in the problem because I've changed it. Now, do you see anything identical that can be canceled out? What is it? The x minus 4s. So then I multiply straight across. 5x times 1 is 5x over x plus 5 times 1 is x plus 5. Can I cancel anything out now? Nope, because this x plus 5 is off limits because there's a plus sign in between it. So this is my final answer. Okay, that's how you do division.